What if I told you that a tree is also a collective of beings, but it is also a garden? It is also the photosynthesis process. One tree, something that we're so used to seeing and analyzing as just one tree, is actually so many things at the same time. And that's what today's essay was inspired about. That was my issue many years ago, on how do we understand nature around us when we do multi-species work. Hi, my name is Emilia Veselova. I am a researcher in multi-species work or multi-species approaches. And today I'm going to be reading out loud an essay that was inspired by this book. So my friend recommended it to me last year, and from reading the first pages of the book, I realized that there's so much potential of learning about scale and analyzing scale and seeing scale that can help us understand how is it that my body is also DNA and quantum particles and atoms and molecules and cells, but it's also a microbiome, and I'm also part of this wonderful planet, and could be considered also part of the ecosystem. So we're going to be looking at that today. And this podcast episode is an read out loud. I'll be reading the we can either struggle with scale or work with it essay that I published this week. And without much further ado, let's get into it, and we'll learn more about me and this podcast as we go. So the essay is a Substack essay. You can also go and read it for yourself if you don't really like hearing my voice reading it. But we'll start with it. We can either struggle with scale or work with it. This is the first essay of the On Scale essay series. And the subtitle is Basics of Scale Theory That Can Help Us Navigate Multi-Species World. Well, it's been a while, an extra week or so, and it's all because of this essay, or rather this topic, which keeps growing from manageable essay to 2 to 4 to more. It all started last spring when a friend of mine recommended me a book. Kata, dearest, I can't thank you enough. And if you are listening, hello, greetings. It's always nice to have you around and also have you comment on how these are coming along. So she had a copy and was kind enough to lend it to me. And this book was The Scale Theory, a Nondisciplinary Inquiry, written by then assistant and now associate professor Joshua DiCaglio. And I will be linking the book in the show notes. Few pages in, I knew I must order my own copy. Some 15 pages in, I knew that this book can fundamentally change how I look at and practice multi-species work. I thought and still think that it can solve many of the challenges multi-species theory, practice, methods, tools, and practitioners have. So today and in the coming weeks, as I said, it is a series, we will talk about scale. Let's call it a first clumsy attempt to integrate scale into multi-species work. Many aspects of the book have probably gone over my head, and some aspects, some discussions I deliberately left out as they did not really seem relevant. So at least for right now, and not at this stage. But scale in its DiCaglio format, and in a bit I'll present and tell you what it is, has such a tremendous potential to help us figure things out. So I hope you let me take you along my journey of thinking and rethinking, reimagining, upgrading multi-species thinking and approaches. So with that basic premise and introduction out, There are a few disclaimers that we need to cover, as always. So first off, if you have any questions, ask Amelia, ask me. So who am I? I have 10 years of experience in researching in the multi-species, regenerative, socio-ecological, nature positive space in sustainability, and how do we bring in nature into our decision making, into design, into different processes, so that we can finally acknowledge and consider this wonderful environment that we live in, and kind of stop being so human-centered. We're shooting ourselves in the foot when we do that. So if you have questions, please leave them. I have a form, and I might answer them either in an essay or maybe a podcast episode. So please do that, and then I can kind of answer some of your burning questions. The disclaimers are that this podcast, the essays and also the podcast, they're human written and human produced. So I do not use generative AI in my writing and in any of my work. All posts have been planned, drafted, written, edited by me. All views are my own and do not reflect those of my employers and other affiliated organizations. Then, as I used to be an academic researcher, but these essays are not part of that world. So please keep in mind, these are not peer-reviewed. They do not constitute scientific theories or findings, and perspectives can change as new information arises. This podcast is also based on a basic premise, and if you have listened to me before or read any of my essays, feel free to skip ahead. The timestamps are in the show notes, but let's cover the basic premise just in case if any of you are wondering. So the idea is that we humans, we're living in a multi-species world. What does that mean? It means that humans, our creations, our lives, businesses, and everything that we do are deeply entangled with the natural world, with all of its creatures, processes, systems, and landscapes. We are directly and indirectly connected through flows of materials, electrical energy, heat, nutrients, but also experiences, emotions, physical and chemical reactions, and even quantum fields. So humans and nature are interconnected in so many different ways, and even there are problematics with what even is human and what is nature. We are a multi-species mesh of things. So humans and nature are inseparable, no matter how hard our education, religion, economy, and personal egos might try to tell us otherwise. We humans need to relearn how to live and do business in a way that sees these interconnections, acknowledges the physical and other limitations of our reality, and drastically reduces the negative impact on nature. If you want to learn more of the basics, check out some of the earlier essays from Multispecies Digest, or watch a lecture of mine that I give on what is this type of thinking, and why do we do it, and how we can do it. And all of that is again linked in the show notes. But for now, let's get back to our essay on scale. Before I jump into defining scale, I first want to share why I have found this conceptual device useful. And what is a conceptual device? It is an idea, a tool, a perspective that provides or represents a different kind of view, a different kind of perspective or order of things. So it's something that helps us think. It's a conceptual design, or if kind of everything that we have in this world is conceptual. We have thought about it. So a conceptual device is something that helps us think. But so why is a scale for me, and in this form that Joshua DiCaglio has given to us in this book, why is it so important? And usually I end with these ideas, but I think it's very important that we cover them now so that we can continue. But overall, it's about three things. And for now, because I think there are much more, and that's why I am writing this whole series, because I think there's so much there. But let's start with the three that I think are important. So first, scale can provide a conceptual structure for the overwhelming complexity of multi-species worlds. So when and we all, if you have ever tried to do it, try to map human nature and multi-species entanglements, then there's no doubt there comes a moment when it becomes overwhelming. So there's humans, there's animals, there's plants, there are tiny insects, there's endless fungal networks, there's microbes, subatomic particles, but also different ecosystems of different sizes. The more you move in and move out, it suddenly changes what you're even talking about. There are also landscapes and light, and whether there is natural light or isn't, and there's photosynthesis process and climate and solar energy, and there's just so much. Maybe you can see that I've done this mapping a couple of times, and there's always so many questions of there's just so much of everything, of different sizes, of different time frames, or how it functions. So kind of a yearly cycle, or then there is these, I don't know, small flies that live a couple of days. So how do you even put all of that together? And the questions are also like, what is relevant? What is not? Do I need to map everything? If yes, then how? And then if not, what do I leave out? And I think many of us in the multi-species space have knowingly or unknowingly used flat ontology when mapping socio-ecological systems. So flat ontology, in crude terms, is this idea that like the things that we see, what we can analyze, kind of, for example, I'm sitting in a room and I can't see the air, but I know that their air is there. So flat ontology is the approach of mapping all people, objects, also ideas, ecosystems, regardless of their size, and also whether they are real. So by real, I mean like, okay, you can touch them. I can touch my physical body. I can touch the microphone. I can touch the computer I'm recording this on. But then also you can map things that are imaginary. So those things that are in our minds, I can map my desires. I can map the cultural patterns. I can mark like social hierarchies and class system that I think is playing out in a particular project. So they're not necessarily, I can't touch the class hierarchy, but I can map it. And then in the flat ontology, you map all of these things on the same plane without hierarchies and assigning them all equal relevance and importance. And then as I read the scale theory, I saw the potential of scale to take us out of the overwhelming space where everything is equal and equally relevant at all times. So kind of popping out of that flat ontology where we need to map everything all at once. And I think it just always becomes overwhelming, and maybe you have a different idea, so please let me know. But so second, why I think scale is useful in multi-species work is that scale and scale-related concepts can provide a solid conceptual structure for why and how one being is simultaneously several beings or types of stakeholders. How I was describing even my body, a tree, not even speaking about a river, because when we say a river, it's like, oh yeah, one thing, but in actuality, it's potentially billions of things there. So scale can provide us the idea of how we can navigate this space through our minds so that we don't go crazy. So ever since a couple of years ago, I think now it's been 5 or 6 years ago, I developed a typology of natural stakeholders for multi-species work. And I'll link an open access publication where you can read about that. But I've known that from different vantage points, each being, be that human or non-human, is simultaneously part of other beings, concepts, processes, and ecosystems. So I'm not just me. I am always a part of many other things. So for example, a tree is not only a tree, but also based on how much we zoom in or out, a tree hosts a variety of lichens, bacterial collectives. It takes part in life processes like photosynthesis and breathing. There's root cells of the tree engage with specific types of bacteria in the soil to carry out nitrogen fixation, which is a process how nitrogen from the soil enters into the tree and so that the tree can actually live and do things. So, but also the tree then is part of an ecosystem and landscapes, and at the biggest scale, the tree is part of the earth. So the tree is part of so many things at the same time. And as we change our perspectives on how much we zoom in or out, or how we see the tree, how we analyze the tree, what the tree is actually changes. And then this is where the scale and some other concepts from this book, which especially logical typing, which I'll talk about in the next essay, can be an incredible guide. So how do we think of an object in multitudes rather than trying to wrongfully and desperately cling to the idea that a tree is just a tree? So the third one is that scale could provide a way to end the, in my opinion, pointless discussion of what is human, what is nature, and whether humans are part of nature. And this is, I might have said it already in the introduction, but yeah, it's such a weird idea, or that we have these discussions. And I've been, as I write, I've been part of so many workshops where the discussion inevitably diverts towards this maddening circular chatter that humans are indeed part of nature, but then why do we still use word nature, that we should stop using the terms human and nature, that's wrong, but then but the humans are somehow distinguishable and special, so maybe it's okay that we use human and nature and so on. And it's just this maddening circular discussion. I've been part of it so many times, and it's especially prevalent, I think, with people who are very new to multi-species thought, and very new to questioning the duality between humans and nature. And I think it's as I write it, because after one, maybe two of these discussions, it's clear that those who are new to multi-species work just have to have this discussion a couple of times. But if you have been working on multi-species ideas for years, you learn very quickly that this discussion is unavoidable, but largely pointless. Like, it does not give much practical or pragmatic progress. With a caveat, I think for those who have these discussions for the first or second time, it is a progress for them. I want to check myself on my own ideas, but it is a progress for them, because if you've never really unpacked this idea that what is human and what is nature, and why do we even use these terms, and are humans part of nature, and most of us have been trained in the Western ideas of human nature separation, and we only focus on humans. So from that perspective, yes, I agree, those discussions can be very useful. But at the same time, if you've been there 3-4 times, you've been there a couple of years, it's like, okay, I get it. Please have your discussion. But this doesn't solve the issues, because the answer to these questions is really complex. And this is where I think scale comes in. When I was reading this book, it's just kind of blew my mind. Because what is human and what is nature, whether humans are relevant to talk about, as we will come to learn that humans are not always relevant in all the scales. It kind of what we talk about, what is human, what is nature, depends on the scale we're talking about. It is a both and situation. So humans are nature, humans are part of nature, and humans are separate and different from nature. But it really depends on the scale we're talking about, and we'll get there soon. So in this and the next essay, I want to focus on the basics of scale, the basics of what I learned from this book, the definitions, key concepts, etc. And then after that, in the series, we'll more talk about then how to apply these basics to rethink multi-species theories, methods, stakeholder typologies, etc. So, but today we focus on the basics. What is scale then? For those of you watching on YouTube, and maybe who have read the essay or have it open with you, you see that the scale, I have a visualization. We'll go back to it later, but for those of you who are just listening, I'll try to describe it. But scale, as I said a moment ago, is a conceptual device. A conceptual device is an idea, a thinking tool that provides us or represents a different kind of a perspective or order of things. A conceptual device helps us think. So scale is a conceptual device which allows us humans to navigate complexity of the world around us. Changing scale changes the reality we talk about and how we see ourselves in this reality. We could see scale as a resolution at which humans observe the world around us. And if you stand in front of a window, now imagine I'm sitting quite close to one. Maybe you are near to one and you want to come up to it. But if you stand in front of a window and look at with your bare eyes, so that would be your resolution A, one of the resolutions that you could have. You would see the window, the clear glass, the wooden frame, the trees outside. Also depends on how close you're standing. But then if you would put a microscope between you and the window, which would be you switch to another resolution B, you would see the dust particles on the window and microbes on the glass. Maybe you don't necessarily see the structure of the glass, but you can see the minute details that you might have missed when you were looking with your bare eyes. So before you were not able to see them with your naked eye, but now through microscope, what you previously could not see is visible. Meanwhile, the previously visible glass, the window frame, the trees have become invisible. So you have changed, you have added the microscope. It sort of has limited the size of, or not this, yeah, the size, I guess, of what you can see. But now you're looking at a very different thing, which exists in the same reality, but you needed this extra tool of the microscope to change what you see. But because now you're looking at through a different perspective, you cannot see what you previously saw. If you would put on even stronger microscope, so again change the resolution to resolution C, you might be able to see the glass molecules, the crystals, or I must admit I've never used a strong enough microscope to see how glass looks under, for example, an electric microscope. But as far as I know, you would be able to see what the glass is actually made of. But then if you would change the microscope for a telescope, that we use, a device that we use to see really far, you would now see far into the sky. You would not see the window, you would not see the frame, but then you would see into the sky, you might see clouds, and then if it's dark enough and the telescope is strong enough, you might see the stars in our Milky Way galaxy and all sorts of different things that are really, really far away. Again, you haven't moved, but you have changed the perspective, the resolution, the device through which you look at the world, from your bare eye to then microscope to another microscope to now to a telescope. So what you see is different, but you're still looking at the same world and at the same reality. So that's what it means if we talk about that. Changing scale changes the reality we talk about. The reality is still there, but what we see in that reality is different. Then another way, a second way to look at scale, building on this idea of we're changing resolutions, is that we could look at scale as this whole array of ways we can look at the universe. So imagine someone, and would be likely not human, being outside of the universe. Even that is kind of an oxymoron. That's impossibility, because one of the key ideas in this book that I don't really cover in this essay is that, well, the universe, the one, encompasses everything there is. So it's impossible to actually go beyond it. But that's a little caveat again. But the idea is that, okay, someone who you're looking outside, just the same way how you were now looking at the window, you would look at the universe, and then there is a whole range of things of course, depending on our human understanding of the world, there's the whole range of perspectives, of resolutions that you could look at the universe through. So if someone would study the universe, then the scale ranging between quantum particles and molecules, so the smallest things in our universe by size, to beings and objects, ecosystems, planets, and galaxies, so the larger things that are in our universe, would show all or most of the possible resolutions through which this person could look at the universe. So a scale, the range, and we'll look at that in just a moment, but it is this whole range of how we can look at the universe. And at each resolution, this person who would be looking in, or you, if you're looking in, you would see different things, different objects would be relevant, like dust particles or glass molecules or the stars in the sky. So by changing the resolution, it changes what objects are relevant, and there would be different relationships, and then different time frames would be relevant. So in cells, seconds might be most relevant, or maybe minutes or days, but then in galaxies, millions of years make a difference. So this is the second way of, we look at scale as this full collection of resolutions through which we can investigate the universe. And now, if you're just listening, I'm now watching if you're watching on YouTube, I now have switched to showing you this range of ideas. But if you're just listening, imagine it's kind of a Russian doll, or nested donuts, or like these nested rings. But imagine a Russian doll. Well, the smallest doll is the Planck length, which is the smallest measure that we know, or human physics have come to learn about, and that is the 10 in the minus 35th scale of a meter, which would be 35 or 34 zeros and a 1. So a very, very tiny scale. But that's where we would start our range of the scale. And then we go, there's 8 steps or 8 dolls that build up this range. And then the biggest one is the whole universe. So there's nothing bigger than the whole universe. And if we would find something beyond the universe that we know, then we would just expand that bigger doll to include it, or either include our universe, or we would just expand what this universe is. But so there are 8 different dolls, and the first one would be the quantum and subatomic level. Here we talk about quantum particles like the Higgs boson, and if you've ever heard of CERN, that's what they're doing. Is we know theoretically in physics that there are these subatomic particles, and then they work and interact with each other, and that's what produces the universe around us. But we can't observe, we physically cannot see as humans into there. But that would be the smallest doll. So quantum subatomic doll. The second doll around it would be atomic or molecular. So atoms, as you might have learned in school, at one point we thought that that's the smallest thing we can divide our universe into, the smallest thing that builds up the universe around us. So atoms, and then atoms form into molecules. But that's yet another level we can look at. And here again, you need very, very strong microscopes, and also other devices that you could study this level with. Then the third doll would be the cellular or unicellular level. We go from atoms to talk about cells. And cell would be, we use microscopes to look at this level. And you've probably noticed I'm not really saying what the meter sizes of these are, because I don't think that's really relevant for the discussion. But so this third level are the cells, individual cells. We don't talk about groups of cells, but just single cells, like a bacteria or a cell on my skin, because that's where technically, I guess, we would see that, or in old ways we would look at, okay, that's where the life starts. So a cell, that's where life has begun. And we have quite a lot of research into how cells functions and what they do and how they relate to each other. But that is, again, a very particular resolution through which we look at the universe. Then, from single cell, we move to multiple cells and we start talking about bodily or normal scale, what Joshua DiCaglio calls in his book. But in essence, it's where we talk about multi-cell organisms to ecosystems in a way. And why this scale is talked like that, we'll talk more in a minute, but it's pretty much the scale where the human body is, or a lot of things that are similar to a human body, like a tree or an animal, isn't there. And it's a scale through which is very easy for us humans to navigate because we do it with our own bare eyes. Even the other three scales, scale domains that we talked about, we talked more about a device that we need as humans to observe that scale than at the bodily scale. We can see things with our own naked eye. And that's why it's called that. Then the fifth doll that encompasses this humans and our bodies would be the planetary and ecological scale. We talk here about landscapes and planet Earth, or any other planet, Mars, Venus, whatever else not. But so we talk about whole planets, and here it's about all of the dynamics on that planet. We think more about we need certain types of telescopes, or as humans we might need certain devices like flying around in an airplane to see the landscapes or continents from above, or a rocket that shoots us out into the into cosmos and we can see how planet Earth looks like. But so it's a next resolution where we need a different type of device to look at, and we look at large scale ecosystems, so the ocean, continents, and planet as a unit. Then, moving on from there, we have a couple more, and these are more cosmic. You need a telescope or other things. For example, we're sending radio signals and then waiting for them to come back in a long, like in decades or so. But so there's different ways how we look at these. But so the three last dolls would be the solar system. So we live in our own solar system. So that would be one, if you think of all the planets that rotate around the sun, one of them being Earth. There's other solar systems in our universe. So that would be the unit at which we talk about, okay, what are the dynamics within the solar system? Then above that, the seventh doll is the galaxies. We are in a Milky Way galaxy, so we would talk about that. And then the final layer would be the whole observable universe. It would be a thing that encompasses everything. How realistic that is, like, we don't know. It's so large. We have no idea. But conceptually, there is a layer that encompasses everything that exists. So that would be the last layer. So again, just to recap, the range of scale is these Russian dolls where we start from the quantum level, then at atoms and molecules. The third level, we talk about cells. Then we talk about a space that is normal for the human body, where we have organisms and objects and ecosystems. Then we talk about planets, then solar systems, galaxies, and the whole universe. And I know it's a little bit or it's quite a lot. But so this is part of that. We talk about scale, and it is this range of things we can talk about. So that's a second perspective, what we talk about when we talk about scale. And then the third way to look at scale, which comes in handy when we need to navigate these, for example, the range of human body, because like a millimeter to a kilometer is a massive direction. So the third way to look at scale that Joshua DiCaglio talks in this book is through the relations between here and there. So he writes on page 30 that scale uses a measure to provide a conceptual relation between two perspectives. So between if I am here and I am there, I can use scale to describe this distance, this relationship. So if you want to imagine in your head, imagine you're standing next to a tree, kind of right next to it. It is a larger than you, if it's like an old tree we're talking about. It's a single individual separate tree when you stand next to it. But if you would walk a bit further, you would see now the tree is part of a group of trees. Like you can still differentiate the tree, but you can see, okay, there's more things around it. And if you keep walking and you walk like 500 meters or so, you will stop seeing the individual tree. And now you see the forest that the tree is part of. So visually, you cannot differentiate your tree anymore. Because you've changed the distance, you now see that tree differently. It has become another thing. So scale here can help you describe this relationship. How is it so that when you are here or there next to a tree, it's a tree, and when you are here 500 meters away, that now it's something else? But yeah, you have not changed the scale domain, and we'll talk about what that means in a second. But meaning you have not shifted to observing world at the molecular level. Like you haven't shifted that, you haven't added a device through which you look at the world, but distance has created a shift, and scale can provide a description how the two perspectives of the tree from here and from there, how they differ. And what I have now been calling at different scales in this book actually has a more precise term for it, which would be scale domain. So let's look at what scale domain and scale thresholds are. So scale domain. By changing the resolution, then we go from one scale domain to another. So if we add a microscope, we go to another scale domain. If we add a telescope, we go through to another scale domain. When we change the resolution, we cross over a scalar threshold. So there is a threshold, which changes what can be perceived. And you can't cross in just by, with your eye getting closer and closer to it. You need a different device to get to it. And maybe glasses or even magnifying glass won't necessarily do it, or depends on how strong your magnifying glass is. But a microscope will do it. Like it will allow you to jump over that threshold. So this scalar threshold that you're crossing is not about getting closer or further away. If I would be moving my eye closer to the window glass, even pressing my eyeball against it, I would still not be able to see the microbes on it. But by using a device or the microscope, I'm able to cross that threshold. We can approximate at which size the threshold happens. For example, it's hard for the human eye to see things smaller than 1 millimeter and beyond 1 kilometer. So that's also why the bodily normal range. So it's hard for the human eye to see smaller than 1 millimeter or above 1 kilometer without a device or some kind of a technology. So think flying in a plane above the landscapes. But it does not mean that this threshold is like this definite line of demarcation where we can zoom into and cross the threshold. And there can be variations. So that's why also, if you saw the images I was talking about, that's why I put these thresholds in a dotted line. So it's not like this clear-cut line. And it also depends on then at what meter size it happens and can also vary. But so again, scalar threshold is more about needing to change the mode of observation and analysis. And so now there's two thresholds. So let's say one would be naked. The top threshold for the bodily and human experience would be, I need a telescope to see further than 1,000 meters away. And then I need a microscope to see lower or things that are smaller than 1 millimeter. So between these two thresholds, that's where the scale domain exists. So a scale domain is a range between two thresholds, and then within a scale domain, or I was previously saying this, like, oh, at a particular scale, so an object and an entity stays relatively recognizable. If you would move towards or away from the window within the bodily or normal scale domain, or at least for the majority of it, the window would still stay a window. Yeah, it wouldn't suddenly appear as millions of silicon dioxide molecules. As you go further away, maybe, yeah, it blends into the building and stuff, but a window stays a window. It's not suddenly a molecule. All right, going forward. One of the key ideas in this book, and I think what really changed, or what really motivated me to look into this topic a lot closer, is this idea that what we see, recognize, and consider depends on scale domain. So whichever scale domain, or at which scale we look at, really impacts how we see the world. And I think that's where I was like, oh, this makes so much sense. This is what really challenges this flat ontology, and it solves the issues that I have been struggling with when mapping multi-species worlds. It's like, oh, these are in different scales. Like, I can treat them a little bit differently, and we'll attempt to do that in the next essays. But for now, depending on the scale domain, what is and how we name it, recognize it, and research it differs. So in DiCaglio's perspective, scale sits above ontology and above epistemology. And I know these are big words. A lot of people hate it. Even some doctoral and postdoc students don't really know what it is. But so ontology is the kind of the perspectives of what reality is, of what is and what exists, or what we could study. So what is ontology, and epistemology is perspectives on what is knowledge, what can we know about reality, and how we can learn about reality, how we can research things, what is appropriate research approach to understand the reality about us, around us. So ontology and epistemology, what is how we study it. So in DiCaglio's perspective, scale sits above that. It's above what is, or how we can study it. By shifting scale domains, so from planetary to molecular, we shift what reality is and consequently change how we can study it. So according to which scale domain you are in, according to which Russian doll you are using, you would claim or see reality differently, and also you would research it, study it, and understand it differently. Like, you would not study a cell with the tools of ecosystems analysis. This also means that what is distinguishable as in and of itself depends on the scale domain we operated. And I am including this here because this idea of in and of itself is a very big thing in multi-species work. If you have ever read about environmental ethics, and then further kind of multi-species justice, that natural entities should have rights, all of that, those discussions in essence go back to the notion of what is valuable in and of itself. So is plant valuable as a plant, or only because it is valuable to humans? Does a bacteria, can we say that it's valuable in itself, and then by proxy, or is it because it's not valuable because it causes disease? Anyway, so this idea in and of itself, what we can name as a unit, is really important in multi-species works, because so many other discussions depend on identifying this, what is in and of itself. So if we apply perspectives of scale theory on that, I reiterate, what is distinguishable as in and of itself depends on scale domain. So depending on these 8 scale dolls, in each of these dolls, in and of itself, what objects are, what we talk about, what relationships they have, would depend on the scale. So, what does it mean? So a normal bodily scale we can discuss, we've discussed that already in a moment, but a human is an object in and of itself. In a bodily scale, human, tree, dog, etc. But at a molecular scale, a molecule is an object in and of itself. At the planetary scale, a continent is an object of it in and of itself, or the planet is an object in and of itself. We cannot see nor distinguish a human at the molecular level. Like, human is irrelevant there. And same as we cannot see an individual human at the planetary scale, a human, one human is irrelevant there too. So the notions that the multi-species work and a lot of environmental ethics rely on, so what is valuable in and of itself, depends on the scale domain we operate in. And I'm really not certain that ethicists or multi-species practitioners recognize this. I say not yet because I hope that we do. But when I read that blew my mind. And I think one of the upcoming essays will be about that. I think it's such a scale perspectives can really expand what we talk about, what is relevant in and of itself. All right, then, depending on the scale domain, we'll have a different answers to three perspectives. So it means that our ontology, epistemology differ. So we would have different answers to what is an object. So a scale changes what objects we talk about, how objects appear, do certain things even exist or are visible at the scale. For example, is DNA visible and relevant at the galaxy scale? I doubt that. Changing scales changes what we talk about, what dominant processes are relevant, what details are visible, observable, relevant. Changing scale domains also changes our language, how we refer to things, what we call some objects, or whether we call them anything. The second one, as we change scales, the second aspect that changes is what is subject and actant, and by proxy, I think, what is consciousness and who can have consciousness. So depending on scale domain, the objects that can act, and by acting an object becomes a subject, so it's able to do stuff and change things. So depending on scale domain, the object that can act changes, and then by proxy, in my opinion, what can have consciousness changes. And I know consciousness is a huge debate, so I won't go there in this series. But then at quantum scale domain, quantum particles are the ones that act, interact, and organize themselves according to their own principles. But at the galaxy domain, galaxies are the ones that act, interact, organize themselves according to own principles. So who and what act changes, or the relevance of who is there and what actions happen changes when we shift scale domain. So shifting scale makes some actants irrelevant while adding new ones to the relevant list. What our process, what our relations, and how things are organized is the third thing that changes. So changing scale domains reveals new relationships, while those from other domains become irrelevant. Whole new sets of relationships emerge when we cross a scalar threshold. What on one scale was a busy, crowded space of thousands of entities like cells appears as one singular unit at another level. So let's say there's a billion of cells and you look at a different scale and it's an ant or a bee. And this new singular unit has a different sets of relationships, processes, and organizational principles. So within a bee, cells have their own ways of organizing and their relationships, and their relationship to this singular larger unit. But when we talk about the bee has a new set of other relationships and how it relates to things. So this new unit still encompasses the entities from the smaller scale domain. We'll talk about that in the last part, but it's now a completely new thing. Think about your body as millions, billions of cells that operate on their own accord. So at the cellular scale, there are millions of cells in the body, but then at the bodily scale, each cell individually is irrelevant as scales are organized under this unit of body. The body is relevant here at the bodily scale. The cells are relevant at the cell scale. And then now let's go towards another important notion and why it's called bodily normal scale. We've already discussed that a couple of times. But so humans and scale. First off, let's be clear that it was the Joshua DiCaglio in this book that named the scale domains, which means that there could have been a different name, different domains, etc. But he had an important reason to naming the bodily normal scale as he did. Before we go there, we need to recognize a few important things about objects and subjects in relation to scale domains. So, first off, organisms, including humans, have a specific size at which the organisms function well. Again, it's important to operate like a human body functions at the bodily scale. A planet functions at a planet scale. So we couldn't squeeze a planet into 2 square meters. It's a meteorite. So, a multi-cell organism like a human body functions well on one size. Meanwhile, a single-cell organism like a single bacteria in a very different size. And I have not yet seen bacteria of the size of a human. Have you? Hopefully not. That would be maybe a little bit creepy. Anyway, so again, organisms including humans have a specific size at which the organism functions well. Let's keep that in mind. Second one is an object, be that living or non-living, can directly act only in the scale domain at which it exists or functions well. Maybe I could correct myself there. But humans act directly without any intermediaries or technology only in the bodily normal scale domain, which is our home scale domain. And I coined this term. I don't remember it from the book. And I don't know what Joshua would think about it. So humans only act in the bodily normal scale domain. Meanwhile, bacteria directly acts only on the cellular level, though through compounding effects, and we'll discuss that in a moment. Many bacteria together can create dynamics at the larger scale, at the bodily scale, when like these bacteria give you food poisoning. But they act on a cellular level. They don't come and punch you in the face. They act towards yourself or through toxins that they release. So an object can directly act only in the scale domain at which it exists and functions well. Next one, humans exist in a particular field of reference. So we as Homo sapiens, yes, you, I, exist in this world in our scale domain. It is the norm for us. All of our experiences are tied to this domain. Our body is really built to operate in this scale, even if we try to experience other scale domains. Our body is not able to truly experience another domain because of our physical size and perceptive apparatus that limits what we can see, smell, hear, feel, and taste. So my body, I can have ideas of how a cell functions, but I will never have experience of a cell. I will never have experience of a bacteria. I will never have an experience of being a galaxy. So humans exist in a particular field of reference only in our domain. Then, anything that is not on human scale is not directly accessible to humans, regardless whether it is larger or smaller than us. And this is really important, and why I include this as we go forward in these essays. A lot of multi-species work tries to build human connections, human understanding of nature. And I suppose, and let's see what happens when I actually delve into or go deeper into that topic, but everything around of nature that is not our size is an abstraction. It's not accessible to us. Like, I can't experience being a river. So I have a lot of questions about multi-species methods and tools that we use. But I digress. So to access scales that are different from human size, people have invented science as well as instruments and technologies. In this essay, we've already mentioned microscopes, telescopes, airplanes, etc. These technologies, devices, instruments allow us to observe, learn about, and access the other scale domains. So think of the Large Hadron Collider in Switzerland at CERN, which humans have built to have a chance to access and see the quantum scale through our limited human perceptive apparatus. So we literally build this massive thing where we collide particles together so that we would have a chance to have a snapshot where we could visually see and prove to ourselves that the quantum layer even exists. Like the Higgs boson was a big thing when it happened, because it was like the first proof that, yeah, we can actually build an apparatus to see the quantum scale, that, yeah, it is there. Again, I digress. I used to be a physics major in high school. This is a bit close to my heart in some ways. Anyways, but we have developed extensive technologies like the cold field of nanotechnology that operate on the cellular level, and now we build wheelchairs for disabled sperm. That's fascinating. Haven't cured endometriosis or ended world hunger, but we are helping sperm have wheelchairs. Fascinating. But making technology to access or make tiny interventions at other scale domains does not mean us humans are actors in that scale. If we send a rocket into space, does not mean that we are now players at that scale. We're just guests, just attempting to do something. Then, anything that is not on our normal domain is an abstraction made by the mind, and the body cannot directly experience it. Humans use our minds to investigate and systemically study our own and other scale domains. So we develop technology, statistical analysis, systems analysis, and many other things to learn about and make abstract descriptions of what a cell is, what a forest is, what a galaxy is, how they function, how those entities and scale relate to human body and life experience. As Joshua DiCaglio writes, the body, as this scale object, cannot go to another scale in the sense of acting on directly on another scale, but the mind, i.e. the mental apparatus, can and does. In fact, it is already made up of and connected into those scalar domains of relations. End of quote. So the idea is that because of our human condition, we are limited only to act in one scale domain. We are mere observers and visitors in other scales, and we have been using the metric system for centuries. So I assume also because we humans will be the ones using this scale theory to understand the world as not an ant, not a cell, not galaxies, not aliens. This is why DiCaglio names the scale domains and we operate in as bodily / normal. Because it is the domain of our bodies, we can experience this domain. It is normal for us. So DiCaglio writes the following, quote, "It is interesting that we have some difficulty naming what I have designated here as bodily normal, only because this is the ground zero of scale for those Homo sapiens defining them. Most terms are inadequate since they indicate too much content about the scale. For example, the human scale implies that it is ours. As a reference point in experience, this normal scale is the perceptual and interactive field on which bodies of Homo sapiens directly act without intermediaries or compounding structures. It therefore also includes very small insects, animals, plants, and non-living structures of the size we routinely interact with." So, the scale domain, the bodily normal, is because it is for our humans. We are the ones living in this scale domain. We are the ones using this scale theory as well, developing it. So that's why it's called bodily normal. Thus, while we humans are rooted, tied to our scale domain, our bodies are optimized to live here. We can use scale theory to travel along the universe and see where we are relevant, where we are not, and how the world functions regardless whether a human is a relevant actor there. DiCaglio goes as far to say that scale in the form that he describes, and we talk about it in this essay, scale occurs outside of human experience and must be somehow represented at the human scale, even if this representation is partial, flawed in certain aspects. But this scale theory is tied to our human identity, sensory apparatus, our bodies. Scale theory is like a tool for our minds to understand the world around us and ourselves, our place, role, and limited relevance within it. So the scale theory, how DiCaglio writes it, and I certainly agree with it, we can't experience scale. We are very limited to what we do as species, as bodies in this world, what we can see, but we can think, we can use this conceptual device of scale theory to understand the world around us. So yeah, for the critics or those striving to leave anthropocentrism, which is a movement, I was part of that idea for a while. No, not really, but the scale theory is indeed anthropocentric, as it departs from human need and presents the world around us in a way that a human would understand. Frankly, don't see a problem with that. If you do, be my guest. I'm ready to read or hear from you. And now, before we wrap up, the last thing, and it's already a really long episode, but I really wanted to cover these basics here today. I want to cover one last idea, which we will further explore in the essays, but I think it's important to start today. So the idea is that things from smaller scale domains form into units and dynamics at larger scales. So before we wrap up, the dog knows it's been a long and dense essay. I still want to talk about the dynamics of how lower scale domains shape the larger scale domains, and a bit also about the vice versa of how the larger ones shape the smaller ones. And I also redrew the scale in a different way. If a first image was more about Russian nested dolls, so here we're more going to talk, it looks kind of like a cake. If you're listening, so like there's layer, it's horizontal lines, and there's first layer, let's say the quantum would be a layer of pastry, and then the atomic molecular would be layer of cream, and then again cellular would be layer of pastry, and so on. So now we're talking kind of layers in a cake. All right. The key idea here, if we talk about how smaller scale domains shape larger scale domains, the key idea is that when we move along the scale, objects change. And it happens both within a single scale domain and if we cross the scale, the threshold into another scale domain. So if we move within one scale domain, we don't cross the threshold, we don't add a microscope, we don't add a telescope. If we move within one scale domain, it's all about logical typing. So, changing bodily relationship to an object changes how we perceive it. As we get closer, larger entities dissolve into smaller ones. Yeah? So, you get closer, you can see that there are smaller things within a larger unit. As we go further away, smaller objects integrate into larger ones, as I was telling with a tree. Close to a tree, you see a tree, you walk away from it, suddenly the tree and everything's around it, they form a forest. That's the principle. So if you are within a city in the bodily normal scale domain, you can see many people, buildings, objects, exchanges, relationships. But if you move away from the city, you see a singular object, so the city in the distance, and it looks like a unified object. If you would move back into the city would again dissolve into smaller entities. So as DiCaglio writes, to speak of the city is to speak of all of these interactions, and yet the city itself is not any one of these interactions. So similarly with a forest, it includes animals, plants, people, interactions, transactions, flows of things and substances, but the forest in and of itself is not any of those individual components. It's a forest. So smaller things combine together to form larger things. And if we see a larger thing, if we get together closer to it, it can open up and present itself as a collection of smaller things. So a new type of entity is created by aggregating, by putting together smaller entities, beings, and exchanges. And then we can break apart a unit that looks solid by getting closer to it, and then we see it unravel into a collection of things. And we can do that within one scale domain, and we do that with logical typing, and we'll cover that in the next essay when I also myself a bit more understand how it works. But so kind of things change as we move closer or further away from them. That's kind of the essence. The next one is that if we move across the scale domain threshold, so we jump the threshold, we add a microscope to our eyes, so to say, it's about the scale shift. So the idea, the principle of smaller things aggregating into larger things remains, but it has a different mechanism. Let's say that at the atomic and molecular scale domain, because it's the smaller domain we can definitely know things about, the quantum layer, as I already said, there's questions of what we can do and know, but funnily enough, a lot of like the woo-woo spiritual practices target this quantum layer because it's the most fundamental layer from which all else aggravates. So if you are ever or have been into like the energy work or Reiki or kinesiology or even prayer and things like that, so what they try to do is impact the quantum layers so that things can aggregate differently, so the quanta can aggregate differently into cells and bodies, etc. And I have even quantum physics books on my shelf, which I really want to look into once I'm done with the scale theory. But yeah, this idea that like the quantum actually plays a big role, but we as humans can't access it. Anyway, I digress. Let's move back into that. When we move across domain thresholds, scale shifts, but the mechanism is different than logical typing. So the idea when we move the scale domains, the overall, as Kallio writes, the domain of possible objects at any given scale is determined by the pattern of aggregation of the scale below. So when we shift the scalar threshold, it's still about aggregation, but in a little bit different way. So from physics, we know that atoms behave in a certain way, and God knows why they do that. So they form molecules, exchange electrons, etc. And then also molecules aggregate and get together with each other, either through physical or chemical processes. So as atoms and molecules get together, aggregate, they fluctuate, so they can create things and dissolve, etc. And this book describes it beautifully, but there was no space in the essay, and also today there isn't much. So through different fluctuations, variations of things, molecules, atoms can create different entities based on how they arrange themselves. So that creates, based on how, let's say, atoms have arranged itself, molecules have arranged itself, that's when create a new object. Like that's when, we can have this type of cell and that type of cell, or this type of material and that type of material. So there's fluctuations, like there's a bunch of atoms and there's different ways how they can form into things. So this new object that the molecules create could be a mass of iron ore, a piece of gold you find in a river, or sand grains, or a cell. And this new object is on another scale domain. So by playing, messing around together, atoms create things on a different scale domain. And then I would be curious how that happened actually. I have no idea. But these objects are in another scale domain, and aggregation, so coming together, has allowed us to go from the atomic to the cellular scale domains. Aggregation of atoms crosses the scalar threshold and becomes a cell. So going forward, interactions and aggregations of the cells will again create distinctly new objects and organisms. So the cell, one cell, yeah, cool. But then if you put many cells together can create an ant, they can create a dog, a tree, a fungal network, they can create a human. So there's so many different ways how cells can come together, aggregate together. And by coming together, then this new object crosses the scalar threshold. So human body emerges from the aggregation of cells, and the aggregated cells, then they greatly shape the body. So the cells that I have shape my body. So smaller shapes the larger, while also the body through its actions can impact the cells. So the larger sets conditions for the smaller one. My body would behave differently if I would live in a hot climate year round. It would adapt to different things, or my body and my cells would have different conditions if I would be a couch potato versus I would train for an Ironman every day. So the body, through our actions, what we do, the body can still impact cells by setting the conditions under which the cells operate. So the idea that I as a human am in charge of and dictate how all cells and processes of my body work is absurd. Like, I can't tell my skin cell what to do. But I do have some impact, and humans have whole research fields, like I think medicine and pharmacology, or like the drugs that we make, trying to help us humans deal with uncontrollable, undesired aggregate behaviors of our cells, or the impact of bacteria and viruses of our cells. So we have created these whole mechanisms, how we as bodies try to shape how the cells at a lower domain behave. So if we look further, all objects at the body normal scale relate to each other, and then through aggregation, these relationships create local and global ecosystems, landscapes, and climate patterns. So like we were talking, like, oh yeah, cells create and play together and they create a body, and then we bodies play together and make different things, create different things, build different things. And through that aggregation, we impact what happens at the planetary scale. Think climate change. We have done that, not each of us individually being like, ooh, yeah, climate change, let me make climate change. But by interacting with each other, by what the bodies and objects, what we do on this scale domain, that aggregates and changes how the planetary level functions. And then the planetary level, climate has changed. Like this year, we have heat waves. So that then impacts the sets conditions for how the bodily functions. And wow, this is getting really long and I'm starting to get tired. Anyway, so as humans collectively, with animals, plants, water bodies, etc., we collectively aggregate into planet Earth. So this idea is very important that on smaller scale domains, things work and fluctuate and create things and live about. And so through that, they create new objects, new processes, and impact the larger scale. And then the larger scale sets conditions. Like me, if I train for an Ironman, I set very specific conditions for the cells of my body under which they functions. So, but when we scale, do entities from other or lower and larger scale domains truly disappear? Because like if I put a microscope to the window, does everything else in the world change? And the answer would be yeah, no, not really. So every part of substance not discernible at a given scale, DiCaglio writes, is properly speaking still there. It's just simply incapable of being registered at that scale, although it manifests in other ways as part of the patterns of the same substance. So even though when I just sit here around, I can't see the air, maybe also the bacteria in the air, who knows what's in my air. It's I don't see it, but it still is capable of creating patterns in my reality. So to kind of wrap up, in scale, it's important to remember that in the same scale domain, we group things to mark their relationships and aggregations into new entities through logical typing. So if we do not jump scale domain, the idea remains that smaller things can aggregate into one object. If we move away, a tree becomes a forest. If we move closer in again, forest disappears and you see a bunch of trees. We do that through logical typing, and we cover that in the next essay. But then across scale domains, so when we cross the thresholds, objects aggregate and form new larger objects on a higher scale. Smaller levels create the larger levels that function according to different principles and have their own sets of relationships. And then as we scale within and across scalar domains, the same object becomes another object, and the object being is never just one thing. Okay, let's recap even that. So, when we cross scalar domains, things that happen in a smaller scale domain create the objects at the larger. The smaller levels and the larger levels, they function according to different principles and levels. So cells within a bee create the bee, but then the bee is a whole different things and have a whole different other sets of relationships. And then as we scale within and across scalar domains, the same object becomes other objects. So if we zoom in or out, or if we cross the threshold, an object or being is never just one thing. And that's where I come back to where I started from, where I was talking about flat ontology and how, we map things. And like, if you start mapping even everything that's in my room at the moment, like the list is endless. But scale can actually help us see these things differently and have some logic. But that's it. I think it's enough for today. I'm tired. You're probably tired. We're in almost an hour and 15 minutes, and this is wild. So let's close the remarks, and then we go into next week's essay, and we go from there. So when I started the scale theory book, here's the book. It captivated me from the first pages. So on the page 3, I read this, and I quote, "What we are able to see, do, react to, develop, and interact with is not only related to scale, but it is a consequence of it. The scale of experience determines in some way what any organism, what we ourselves, is able to see and do. Yet these Homo sapiens move beyond this scale of experience as science's scalar descriptions saturate our ways of speaking and thinking and intervening." And this is the idea that keeps me going. We humans, we live in the bodily domain, but we have also such extensive science and things to help us understand what we do with scale, how we impact other things. But it doesn't mean that it doesn't come with like challenges. Like, I think this is one of the reasons why it's so hard for people to understand climate change, because it's like it's out of our experience, unless it's like a direct heat wave, or we think like, 10 years ago Finnish winters were much colder. Like, it's already too late when we feel the impact of climate change that happens on a different scalar domain. Now it's entered into our lives. It's setting conditions for our lives. And it's like, oh, okay. But so with scale theory, we have such a capability by bringing it into multi-species works to really help us navigate, to like help people think. We are capable of thinking about other scale domains, and that is beautiful. And this is why I'm doing this whole series on scale theory, because I think it's going to be fascinating. Yeah, it's the idea that keeps me going, that we can use scale to help us navigate the world around us. And unpacking how scale shapes multi-species work is crucial. So scale matters, but we also overlook it so much. Like I never thought of this before reading this book. And I really think of like scale informed multi-species approaches, and that's the goal of this series. And I know that it's for those of you who read the essays, it's a shift for regular programming. So if you want to stick around, please do. If you don't. I think today has been a long essay. It's been so much longer than I anticipated. But yeah, it's this book, this scale theory has really changed so many things for my mind. I really hope that you come along for this journey, and I also really enjoy recording these essays as in podcast form. It really helps me think through. So thanks for coming along for this ride. If you enjoy this, please comment, share, consider subscribing, send it to a friend who might find this useful, and then I really hope to see you in one of the next essays.